Alright, hello my wonderful students. This is part 2 of Foldable number 3. For this one, we're going to be combining radical expressions once again. And we have the 5th root of y squared times the 8th root of y cubed. So we're going to go ahead and write this in exponential form. So we have y to the 2 over 5 times y to the 3 over 8. So the 3/8 and 2/5. We have the same base again, so we can go ahead and use our product rule, so our P rule, like we did from the previous, I mentioned in the previous video, and that's saying that since we have the same base, we can actually say it's y to the 2 over 5 plus our 3 over 8. Can't really add this per se. So what we can do is we can get our 2/5 and 3/8 and find our lowest common denominator, or our LCD. So our LCD is most likely, this doesn't really have any primes that do it together. So we're just going to multiply our 5 times our 8 and get our 40. So our LCD is actually going to be 40. That being said, this is going to be equal to our y times 2/5. But in order to make 2/5 40 on the denominator, we have to multiply the top and bottom. I'll do it in red so you can see this part. 8 over 8. And this is going to be plus our 3/8. And once again, we're going to multiply this by, in order to get 40 on the bottom, we have to multiply by 5. So we'll multiply by 5 over 4 to make sure both of these are 1. 8 over 8 is 1, and 5 over 5 is 1. So this would change into, go ahead and rewrite this. Oh, can't do that. I have to leave it here so it's in the middle. So this is going to change to, am I in blue? Yes, I am. This is going to change to our y to the 2 times 8 is 16 over 40 plus our 3 times 5 is 15 over 8 times 5 is 40. And this is going to be equal to are 16 plus 5, because they have the same LCD, y to the 31 over 40, which seems like a ridiculous number, but we're just going to go ahead and rewrite this. So you know what, I'm just going to write this again here. So we have y to the 31 over 40, and this will convert to the 40th root of y to the 31st power. And just to remind you how this works, these are our two answers here. This one here is going to be our exponential answer, or exponential form, I guess you can say. And this right here is going to be our radical form. So depending on what the answer is asking for, you need to pay attention if it either wants the exponential form or the radical form. Alright, same thing over here. We have, well, a little bit different. We have our 7th root of x to the 4th divided by our 3rd root of x squared. We're going to go ahead and rewrite this in exponential form. We have x to the 4 over 7, or the 4/7, and x to the 2/3 power. And because this is a quotient rule like we had in the previous foldable, or the previous video, we have this is going to be equal to our x to the 4/7 minus 2/3. And once again, now that we have the quotient rule and we're doing our subtraction, we can simplify by finding the LCD, which I'll do this one in red. So our LCD is going to be equal to, once again, since they're both primes, we're just going to multiply the two numbers together, and it's going to be 21. So our LCD is actually going to be 21. So that means we have to rewrite these in order to get 21 as our denominators. So in order, we're in green, in order to make this our denominator, we have x to the 4/7, but to make this 21, we're actually going to have to multiply the numerator and denominator by 3 over 3, because 7 times 3 would give us our 21. And we're doing subtraction still, and we have our 2/3. But in order to make the denominator 21, we're going to have to multiply this one by 7 over 7 as well. All right, that being said, we're going to have our x to the 4 times 3 is 12 over 21 minus our 2 times 7, which is 14 over our 21 as well. And this is going to be here. Remember, this is all in the power. It doesn't really select that. I can make our x bigger to show that it's in the power. And then once we do this, we have our x to the negative 2 over 21. But we can't have negative exponential values. That means we're going to have to convert this into a 1 over x to the 2 over 21, which is the same thing as saying, oh, that's going to be a problem because it's going to be the 21th root. So we can go ahead and write it over here. So it's going to be 1 over the 21th root of x squared. But we can't have a radical in the denominator. So it's going to rewrite that here, 1 over 21th root of x squared. So we have to multiply this by a 21th root of, that's 12, 21th root. We have 2 copies here, so that means we would need 19 more copies in order to take it out because we had 21 total. And we have to multiply it by the same thing. So we have 21th root of x to the 19. And this would make it the 21th root of x to the 19th over the 21th root of x to the 21. These will reduce out, leaving us just with x in the denominator. So our answer is actually going to be the 21th root of x to the 19th over x.